Business logic component, otherwise known as a block, is arguably the best way to do state management on Flutter. Events come in, state comes out, and the flow of data simply has to be predictable this way. Writing your apps using the block pattern from scratch creates a lot of boilerplate code though. That's why there is an amazing library which spares you from dealing with the intricacies of block like streams and sinks. I have already covered the block library a while ago, but back then it was just a cool library to use for enhancing your codebase. Today, it will change the way you develop Flutter apps for the better. Hello, welcome to ResoCoder. You're going to learn how to use the block library by building a fake weather app which just generates fake weather data. We can enter a city, New York, search for it, and it's going to generate us some temperature. And be sure to check out the written tutorial which is available from the link in the video description. Over there is also all of the code written in this tutorial and all of the links to all the different libraries. Let's get started by importing all of the libraries over to our pubspec.yaml file. While for developing with the block library on Flutter you only need this library, WeatherBlock, there is also another Dart package which fits just perfectly with block, and that is Equatable, and it's actually from the same author. And the role of Equatable is to simplify value comparisons on Flutter or on Dart, because by default equality on Dart is referential and not value equality, and Equatable sets out to change that in a simple way. We want to add WeatherBlock and also Equatable as dependencies in the pubspec YAML file. Once you have that, you also want to add an extension to VS Code, and also the same extension is available for IntelliJ and Android Studio. On VS Code, you want to search for simply Bloc and install this Bloc extension. This will allow you to develop even faster with the Block library. With all of these libraries and extensions installed, now it's time to do some coding. However, you cannot really have a Flutter app without a user interface, but because this is not a tutorial about making UIs, you can simply copy and paste the starter UI from the written tutorial on resocoder.com, which is available through the link in the video description. Once you copy and paste it, you're going to be left with something which looks like this. When we launch it, it's going to look like this, and it doesn't do anything special, but we can enter a city, and this is what the block will be connected to, but currently it obviously doesn't do anything because we first have to write the block. Firstly, if you are just starting out with Flutter and you are not entirely familiar with the block pattern, just realize it's nothing mysterious. All you have to remember is that the block, which stands for business logic component, is like a pipe. Events, for example user input values, like this input value for a city name, come into the block, then the block runs some code in reaction to the event coming in. For example, the block retrieves data from a fake API, in this case it generates temperatures, and subsequently block outputs the state, which you can think of as a package containing data, and then we can grab that data and display it in these text widgets. As I've said, every block needs events, states, and obviously the block itself. So we need 3 classes. And that means probably you also need 3 files. And while you could create all of those Dart files manually, there is a better way with the block extension. So just right click on the lib folder, and we want to use block, new block down here in the menu. Now we're gonna be prompted to give a name to the block, so let's just call it weather. Hit enter, and we do want to use Equatable, so select yes, and now the block was generated. This folder, which has been just created, contains 4 files. One of them is the so-called bearer file, which just exports all of the 3 other files so that we can import them in just one import statement. And then we have all of the goodies in here: weather state, weather event, and weather block. Let's start out with weather event because that's what is going to be coming into the block. The first question you should ask when implementing events is which actions from the UI will need to trigger some logic. In our case, the only thing which will trigger something is when the user inputs a city name into this text field. We already have an abstract class weather event from which all of the other weather events should inherit, and it extends equatable for making value equality simple to use. Now we want to create an event called getWeather, which will simply be a class extending weather event, and then we also need to handle data which needs to be passed into the block, which in this case is the city name. So we are going to add final string city name, and let's also add the constructor which will set up this city name field. And also, because this class is extending weather event, which in turn extends equatable, we need to pass in the city name field into the super constructor. Doing this will allow for simple value equality. That means two instances of getWeather, which have the same city name, but they are two different instances, will be equal. Otherwise, by default in Dart, only two of the same instances are equal. Data equality just doesn't play a role. Now that we have the event which will come into the block, let's also implement weather state, which will be coming out of the block. When implementing states, you should in turn ask what will the block output in reaction to the incoming events so that the UI can react to this output. Well, we first need to have some kind of an initial weather state, but we are actually going to rename it to say weather initial because it's just simpler. This is the state before the user inputs any kind of a value. But then, once the weather event getWeather is dispatched, something needs to happen inside the block, and we want those changes reflected in the UI. When the weather is being loaded in the block from a fake API, or in other words, it's being generated with a delay, because we are really just faking an API, the UI should show a loading indicator. So we need to have some way to let the UI know that it should show the circular progress indicator, and that can be done with a custom state, weather loading. And once the weather is actually loaded, another state will be outputted called weather loaded, and this will come with a weather so that the UI can grab that weather and display it inside these text widgets. Again, because weather state is extending equatable, we need to pass in the weather field over to the super constructor. But we have some problem here because weather is not yet implemented. Weather will be only a simple data class holding city name and the temperature, so let's create it inside a new folder under lib called model. The file name will be weather.dart. We first want to import equatable and also the meta package, and then we're going to create a class weather extending equatable. Final string city name, final double temperature are its fields. And finally, we want to set those fields up inside a constructor and then pass those fields over to the super constructor of equatable. After you have carefully thought out what will come into the block in the form of events and what will come out of the block in the form of the states, and also over in weather state we should import the weather class which we have just created, you can finally implement the block itself, which will take in those events and output those states. If we take a look at the already generated block code, it comes pre-configured with the initial state getter and also map event to state, where even the comment says this is where the logic will happen. So what is actually going on inside map event to state, which takes in an event as we can see, and then it outputs a state, but not just state by itself, but it outputs a stream of state. Well, under the hood, the Bloc library works with regular Dart streams, and this async asterisk keyword means an async generator which outputs a stream. Stream is basically just a sequence of multiple objects. Then we can listen to this stream inside the UI and update the UI whenever a new state is outputted. So what exactly do we want to do here? Well, we first want to check for the event type, If you have multiple events and not just one called getWeather, which is probably the case in most apps, this is how we can distinguish between the events. And then as soon as we get the getWeather event, we want to indicate to the UI that it should display the loading indicator. The yield keyword here is used to output a new object into the stream. Immediately after that, we want to actually get the data from the fake weather API, and we access the city name on the event so that we can get the proper data for the city which the user wants. And once we have the weather, we want to output it with a weather state. So we are going to yield weather loaded and pass in the loaded weather. This is where you would obviously call your real API or do something completely different, but we are using a fake API, so let's create a method for generating the weather. The method's name is fetchWeather from fake API, and it takes in one string containing the city name. We simply want to return future delayed with the duration of the delay of 1 second. This is just simply to simulate the network delay. And then the thing that we want to return from this future delayed is a weather which will contain the same city name, which was passed in from the event basically. And then the temperature will be a random temperature between 20 and 35.99999. And we are simply using the Dart math package to get the random numbers. Then we also need to import the weather class, and with that the block is finished. Events come in, state comes out, and now we need a way to listen to that state from the UI. So let's jump into main.dart, and we need to realize that the UI has two roles. UI dispatches events to the block to initiate some logic, in our case the getWeather event, and then it also needs to react to states emitted from the block to update the displayed UI. Let's first take a look at how the UI is actually written. We have one weather page, which contains a scaffold and then a container containing a column, and then two simple text widgets, one displaying city name and another one displaying the temperature, and then we have a custom widget for the city input field, which contains a text field, and whenever the text field is submitted, the submit city name function runs. Now that we know how the UI code looks like, let's first handle updating the UI whenever the state changes. This is possible with a widget which comes from the Flutter Block library called Block Builder. Inside weather page state, we are first going to make this column into its own separate method. So we want to extract method, and we are going to call it build column with data. This method will take in the weather. So let's also import weather. And once we have that, we can jump into using the block builder. It will be a child of the container, and to use block builder, we can actually use the code snippets which come from the block extension. So just block builder, select that snippet, and here we need to specify a block. Well, our block is called WeatherBlock, so we can instantiate it even right here, can't we? Well, let's try it. So WeatherBlock, and then import WeatherBlock. Then the state will be weather state. So let's actually import the barrel file here. And we also need to import block builder from the Flutter Block package. This builder is where we'll be able to react to the state changes and output a different UI for different states. But let's first take a look at why we should not create a block instance directly over here. That's because block uses streams, and streams need to be disposed of. This disposal needs to happen inside a dispose method, which every state class has. And if we go into the dispose method, we actually need to create one all the way down inside the state class, create dispose. Well, how are we going to access the block instance if we have not put it inside any kind of a field? That's why we cannot instantiate a block directly over here, but instead we need to create a field here, final WeatherBlock, which will immediately be made equal to the WeatherBlock instance. And now we can go and specify the block inside the block builder to be the WeatherBlock, and also to dispose of the WeatherBlock over in the dispose method. So WeatherBlock.dispose. And now over in the builder function, we want to react to the state changes. So first, if state is weather initial, we will want to only build the initial input, which doesn't show any of the city name and temperature. It just shows the text input field. Then, if state is loading, we want to show the loading indicator. And finally, if state is weather loaded, we want to show the column with data which contains the city name, temperature, and also the text field for next input. Build column with data needs a weather passed in, and we can access that weather from the state because weather loaded state contains the weather field. So let's just quickly handle build initial input and also build loading. These are two simple methods which simply return center widget containing the city input field for the initial input, and then build loading simply shows the circular progress indicator. We also need to change the code inside build column with data because now we want to use that weather and show the data contained inside of it. So instead of hard-coded city name, we're going to say weather.cityname, and then instead of 35 degrees Celsius, we are going to say interpolated weather.temperature.toString as fixed, because we want to show only a certain number of decimal places, and those will be only one decimal place. So by now we have successfully handled the changing of the UI whenever the state changes. But that's not all that useful because currently the state will never change. That's because we are not passing in any events into the block, and if no events come in, the state will be always equal to the initial state. So we also need to somehow pass the getWeather event into the block. The place from which we want to pass that event into the block, in other words, we want to dispatch that event, is from the city input field. The problem is that the WeatherBlock instance which we have created here is present inside the state weather page state, but the city input field is its own class. So we cannot just simply access this WeatherBlock field from the city input field. We need to have a way to pass this same WeatherBlock instance even over to the city input field, which is a different widget. The Bloc library provides a block provider. This is an inherited widget made specifically for passing blocks down the widget tree. And since the city input field is nested inside the weather pages container right over here, and also right over here when we are just building initial input, we just need to wrap this outer container with the block provider. Technically, we could also just wrap the block builder with the block provider, but let's just wrap the container. So for wrapping the container, we can utilize VS Code and Dart code extension because we want to wrap it with a new widget, and this widget's name is block provider. This obviously takes in the child, which should remain to be the container, but also block provider needs a block, and the instance is our instantiated WeatherBlock. Now all of the widgets down the widget tree can access the instance of WeatherBlock, and obviously this applies also to the city input field. So over here, whenever the text field's value is submitted, we want to submit the city name to the block. We first want to get the instance of the WeatherBlock by calling block provider of, specify the type of WeatherBlock, and then we need to pass in the build context. And once we have the instance of WeatherBlock, we can dispatch a new event to it, and that event is getWeather, which contains the city name. And now when we save this and go into the app, we can enter a city. So this time Bristol maybe. Input that by hitting this search button on the keyboard. The text is submitted, and now we have Bristol with a generated temperature, and we can search for San Diego. And again, the temperature will be generated. State has changed, so the loading indicator is displayed, and subsequently the weather loaded state is outputted, so we have a new temperature with the city name displayed inside the UI. Technically, this is all you need to know about Bloc, But what if you want to, let's say, log the loaded city in reaction to an emitted state? You would, for example, do this to keep a statistic on how many times a particular city has been requested. Well, that's simple, isn't it? We can just plug that functionality over into the block builder itself. And so, for example, whenever the weather is loaded, we would first print the loaded city name, so loaded, and then interpolated string containing state dot weather dot city name, right? Well, the problem with this approach becomes apparent once we open up the console. If we now try to search for a new city like San Francisco and we hit the search button, San Francisco will be outputted into the console, which is perfectly fine. But now, when I hit Ctrl Save to do hard reload, San Francisco is output once more. Another hard reload, and another San Francisco comes in, and this will go on and on and on with every subsequent hard reload. And obviously you are not going to have hard reload in your production apps, but the point I'm trying to make here is that you do not control the rebuilding of the UI. Flutter is controlling whenever it decides to rebuild the UI. And whenever the UI is rebuilt, the builder function will simply run. So if you are trying to keep a statistic on how many times a particular city has been loaded, Block Builder is not a good place to put that logging code into. To execute code really only once per state change, we need to use another widget, and that is the block listener. And obviously, all of this applies to showing things like snack bars or navigating to different routes, because you don't want to show the snack bar twice, and you don't want to navigate twice to the same route. In short, Block Builder should only build the UI widgets, it should not do anything else, and then all of the other functionality should go into the block listener. Block Builder is therefore the so-called pure function because it doesn't have any side effects and it only returns a widget. It doesn't do anything else. Everything else needs to be done inside the block listener. So let's add that block listener, which will instead print this loaded city name. Usually you pair the block listener with the block builder, so let's make this block builder a child of the block listener. So again, let's use VS Code. We want to wrap with new widget. This widget's name is block listener. This also needs to take in the block instance. So block is WeatherBlock, and then the listener is a function which takes in context and then also state of type weather state. Similar to how we can check for states inside the block builder, we can do the same inside block listener. So if state is weather loaded, and if it is, we simply want to print the city name of the currently loaded city. And now once we go into the app and we search for another city, for example, Anchorage, and search for it, it's probably too hot for Anchorage, but we are going to ignore that. But when we open up the console here, other than having some weird Flutter errors, we also have the message that we have loaded Anchorage. But now whenever we do hot reload, we can only see that the hot reload was performed, but the message that we have loaded Anchorage is not duplicated. That's because block listener really runs only once per state change, and not whenever Flutter rebuilds the UI. You can get the code written in this tutorial from the link in the video description, which is gonna take you to resocoder.com, from which you can learn at your own pace. Subscribe to this channel if you don't wanna miss more tutorials like this, and also hit the bell button so that you join the notification squad, and you will be notified therefore about every new video that I upload, because here on ResoCoder I am determined to provide you with the best app development material and tutorials out there. If this tutorial helped you, give it a like and also share it, it really helps a ton. Leave a comment if you have anything to say, follow me on Instagram, Facebook and Twitter, and see you in the next video.